Hey guys, this is Miss Sarah. I'm back with my next lesson. I hope you guys are doing great. I hope you guys enjoying your force break. Anyways, so let's just move on. Alright, so today's lesson is still 8-1. We are still learning about integral of exponential functions. Today I'm going to show you a few more examples. Like, here comes my first example. I have integral of 1 plus e to x, and there's a square on the top. Now, the way you can approach this problem, like you can simplify first, you can expand this out. Like, I hope you remember this pattern. So I have a plus b and there's a square. If you have to expand this out, you could write it out twice and distribute, or there's a shortcut. And the shortcut is a squared plus 2ab plus b squared. So I'm just going to follow the shortcut. So if I expand this out, so a squared means 1 squared, which is 1. Plus 2ab, which is 2 times 1 times ex, and plus b squared, which is going to be ex, and there's a square on the top. All right, now let's just simplify. So I know once I have to integrate, so pretty much first I need to simplify. So this 1 would stay the same, 2e to the x, and this piece simplified as, my bad. This piece simplify as it's e to 2x, because eventually this 2 and x gonna get multiplied, becomes 2x. Now once it becomes integral problem, it's basically integrating every single function, every single piece of this expression. Integral of 1, which is just a constant, it's just going to be just x. Integral of this piece, you can pull out the constant, which is 2, and you can take integral of ex, and this one I'm just going to rewrite it. So x, I'm done integrating the first term, which is x. Second one, 2 would stay the same. Integral of e to the x, it's just the function itself. Now the last one. Okay, now try understanding yesterday's lesson. If you have e function and this is not just x, it's different than x. So then that expression you should attach with the derivative of this piece. What's the derivative of 2x? It's 2, which is not there. So this is where you need to bring in the number. So I would do 2 over 2. Now the top number would complete the pattern, and you need to factor out the extra number, which is 1/2. So I would factor out 1/2. Now this whole thing would complete the pattern, so the integral of that part would be e to 2x and plus c at the end. Here you go. So that's my first example. Let me show you one more. Let's say I have e to 3x plus 3 times e to x and plus 1, and we are integrating this whole function and whole thing. This whole thing is dividing by e to x. Try remembering, this is integral. We do not have any product or quotient rule, so you can't do quotient rule on this. Instead, since it's one big fraction, I can split it in two small fractions. Like, I could rewrite e to 3x divided by e to x, 3e to the x over ex, plus 1 over e to the x. And then I can just integrate every single piece. But first, make sure you simplify. So like first one, I know I could simplify e to 3x divided by e to x. Means you can cancel out one of the ex, so you're left with e to 2x, and then you can integrate after that. This e to the x got canceled out, so you just have to integrate just 3. And the last one, in order to integrate that function, I would move that e to the top, and this x becomes negative. Now this is just normal integral after this step. So let's just find the integral. This one, again, it's e to the 2x, means it should have 2 in there, so I would bring in 2 over 2, factor out the extra number, and this becomes e to the 2x. Move on to second piece. It's a constant. So integral of a constant would be just add an x to that. And the last one, it's another e function. So now you need to check the derivative of this piece. This should have derivative of this piece, which is -1, but it's not there. This is where you need to bring in the number. So top number completes the pattern. I would factor out the bottom one. So this becomes -1 outside, and e function stays the same and plus c at the end. Here you go. That's my answer. And another one. Let's say I have another example is e to x. Then I have cube root of 1 minus e to x. All right, integral of this and dx at the end. Let's try rewriting this. I have e to x, 1 minus e to x, and let's just say this is 1/3. Yeah, makes sense. This is just simplifying. Now let's try doing different stuff. I know this whole part going to be my original equation for sure. But okay, this is just try recalling chain rule for derivative. So it means it's more like chain rule problem. So if this is my original problem, it should have its derivative attached to it. All right, so derivative of this piece is e to the x, which is here. And don't forget, there should be a negative in there because derivative of this one would be negative e to the x, right? What I see is it's just, oh gosh. Oh, my bad. I'm sorry. Oh, I'm really sorry. So what I see is I just see e to the x, means there's a negative missing. So first thing I need to bring it in is -1 over -1. Because originally what I see is this must have been like your chain rule problem. So I'm trying to undo chain rule. So this is my original expression. It should have its derivative attached to it. Yes, it is the derivative, but there's a negative missing. So I already brought in the -1 over -1 to complete the pattern. Last step. Okay, now this piece just going to go away because it completes the pattern. So as this. So what I would do is I would just add 1. I hope you remember integral, and you need to divide by the same thing. So finally, my answer would be this -1 for sure. This whole expression, 1/3 added 1, this becomes 4/3, and I would divide by the same number. Almost there. And last thing, add c, and don't forget to simplify this 4/3 in the denominator. So it's basically multiplying by the reciprocal. So finally simplify to -3, 1 minus e to x to 4/3 over 4 plus c is my final answer. Here you go. So pretty much I have this is my answer. So for this problem, there's another way you could actually do these problems for, like you could still use sub for these type of problems. I'm just gonna show you a quick example on use sub. It's pretty simple. How about if I have e2 1 over x, and it's over x squared, it's dx, and it's the function itself. We're trying to do u substitution on this. So every time you do u substitution on any of these e problems, always make the exponent equal to u. Whatever the exponent, make it equal to u. Don't forget, you cannot make x is equal to u. You can make exponent equal to u if that x is different, if that x or exponent is different than x. So this exponent is different than x, yes, I can make it equal to u. So let's just say this u is equal to 1 over x. I hope you remember, it's always easier to take the derivative of this side first. So I would do du over dx. Let's take the derivative. I would move this to top. Take the derivative. -1 times x to the -2, which eventually going to be this. All right, now back to my original equation. Let's try substituting everything in terms of u. I see e. Now 1 over x, I already know we substituted for u. Now I have dx and x squared still left in this problem. It needs to get replaced with u. So e to the u is already there. Dx over x squared. So let's go back to this equation and let's try doing cross product. Or you can multiply by dx both sides. If I multiply by dx both sides, let's see what happens. So this becomes du is equal to -1 du over x squared. If I take you back to this equation, I have everything in terms of u except this expression, which can be solved over here. So I know du over dx, du over x squared can be simplified. I can divide by negative both sides. So you know du, oh my bad, this is not du, this is, because if I do cross product, it would be dx here. So this becomes dx over x squared, and it's d divided by -1 becomes negative du. So to me, this whole expression is equal to negative of du. Almost there. Now, time to take integral. So I can factor out a negative. Integral of e to the u function, you know, it's going to be just e to the u and plus c. Time to bring in the original function. So I have -1, and I know u is equal to 1 over x, and it's plus c. Here you go. That's how you can do it by u substitution. So again, let's do a quick review. So just set the exponent equal to u. On the side, I'll take the derivative. I'll solve this equation, or I'll do cross product for whatever I needed to solve for. Plug it back into original, and then here you go. That's pretty much all. So thank you for watching, guys. I'm sorry, it's kind of like long video, but I'm really sorry. So anyways, if you still need help on anything, let me know. Just can send me a comment, and yeah, thank you. Thank you for watching. Bye-bye.